Hi there, everybody. We're going to get started in just a minute here, looking at simplifying rational expressions and finding excluded values. This being part of actually one of our last topics that we're going to cover in Algebra 2 this school year. All right, folks. Well, in the interest of time, I'm going to go ahead and start talking through some of this here as more of you guys join in. Today is the 27th. This is for all of my class periods. So, simplifying rational expressions and factoring. You, of course, going to factor the numerator and the denominator in a tour, if possible. So you look at this one here, the top being 18x minus 45, the bottom being 45x minus 90. Up at the top, you can pull a 9 out of both of these. 18 divided by 9 is 2. That's why I have a 2x here. And 45 divided by 9 is 5. Alrighty. And between 45 and 90, the whole thing, 45, it goes into both of them. Of course, it goes into there once, and it goes into 90 twice. So here is our expression factored. Then we want to identify common factors that are common to both the numerator and the denominator, and then divide them out. Okay? In other words, we have a 9 and a 45. 9 does go into 45 5 times. Alrighty. So we're just going to, well, up top, there's nothing but the 2x minus 5 remaining. You can have that in parentheses or not. It's your choice. And then there's a 5 on the bottom. Okay, and that is it. That's fully simplified. All right. Now, we are going to do factoring here. And I know we haven't talked about that really at all in this Algebra 2 course. You've done it in Algebra 1. In this unit, there's two main ways to factor. The first is done above, is GCF, or greatest common factor. Okay, so use GCF to factor this guy here. You're going to look at it in two separate pieces. First, the number, and then the letter, the variables. We have a 3 and a 6. 3 goes into 3, and 3 also goes into 6. Okay, this x squared, that means there's two x's, and this being a single x, that's 1x. So you can pull 1x out of both of these. All right, you can't pull two x's out of here because there's only the 1x. So 3x is going to be our common factor. All right, 3 divided by 3 is 1, X squared divided by x is simply x. Keep that minus there. 6 divided by 3 is 2. And x divided by x, it just goes away. So there we go. 3x times the quantity x minus 2. And if you want to check that, you can distribute it back. 3x times x, 3x squared. 3x times negative 2, negative 6x. Alrighty. So let's take a look at this one here. 36 and 45. Well, I know 36 is going to be 9 times 4. And I know 45, especially since we did that number already, is 9 times 5. So we can definitely pull out a 9. This one has 4 x's. This one has 3 x's. So you can pull 3 out of both of them. Okay, 36 divided by 9 is 4. And if you pull 3 x's out of there, you've got 1 remaining. 45 divided by 9 is 5. And we pulled all 3 x's out. So that is that one. All done. Okay, GCF factoring can be thought of as applying the, like I mentioned before, distributive property. Distributive property backwards. Okay, now trinomials. This is something that you definitely did in Algebra 1. We didn't really talk about it at all in Algebra 2. For solving quadratics, we went for quadratic formula and completing the square. Both of these can be used in a sort of different way to get the factored answers, and I can talk to you about that in another video or offline. The second method is mainly used for factoring quadratic expressions, or excuse me, quadratic trinomial expressions. Trinomial expressions. This method involves finding two numbers that yield a specific product and a specific sum, which is not spelled with an A, in case you were curious. There we go. Sum. All right, so here's how this goes. Identify two numbers that have a product of 4 and a sum of 5. What I like to say is if the two numbers don't pop into your head within, I don't know, 10-15 seconds, go ahead and just start making a list. Okay, we're looking specifically at the number 4. Things you can multiply to get 4. Does 1 go into 4? Yes, it does. 4 times. 1 times 4. Does 2 go into 4? Yeah, 2 times. 2 times 2. Does 3 go into 4? No, it does not. Does 4 go into 4? Certainly does, but we already wrote it down. So we don't have a whole lot of choices for 4. And these two, when you add them together, do give us 5. So it looks like this is going to be x plus 1. There's our 1. And x plus 4. There's our 4. All right, so that's just a quick little review of factoring. Okay, so real quick, factor this guy here into 2 binomials. Alrighty, well 3, there's not really any choices other than 1 and 3. 2 doesn't go into 3. 3, we already have it there. So this is going to be something. However, this is negative. Okay, if you remember the product of 2 that are the same, so if we did positive times positive, that would give us a positive 3. But also at the same time, a negative times a negative would also give us that positive 3. And since that's negative, well, a negative 1 plus a negative 3 is going to give you that negative 4 that we're looking for. Okay? All right, so there's that one there. For this one, we've got 4 at the end. Again, if it doesn't just pop into your head right away, 1 times 4 and 2 times 2. Those are the only real choices. And 2 plus 2 does give us 4. So it's going to be x plus 2 times x plus 2. All right. Now I've got a couple of other ones down here. So let's take a look at the 64. This one does have a bit to it. Again, if you know what it is within 10-15 seconds, go ahead and just start going. But if that amount of time has passed and you're still going, gosh, I really have no idea what the two numbers are going to be, just start making a list, okay? And start at 1. Does 1 go into 64? Sure, 64 times. And that's going to be 2 times 32, okay? 3 does not go into 64, so we'll skip that one. 4 does, that's 16 times. 5 does not go into 64. 64 divided by 6 doesn't come out evenly. 64 divided by 7 doesn't come out evenly. Divided by 8, though, sure, we can do 8 times 8. All right, 9 is not a factor of 64. Let's see, 10, 11, 12, nope. 13, 14, no. 15, no. 16, you know what, we already did 16, it's right here. Okay, so this is it. These are all of our choices. So now we're just looking for the ones that when I add the two numbers together, I get 16, which is going to be that one right there. It's a pair of 8s. So we've got x plus 8 times x plus 8. And since it is the same thing, multiplied by itself, you could also write it as x plus 8 squared. Okay, that's going to be important for later. And guys, pretty much the same thing applies here. Again, 100, if you're not sure, you can go down the entire list, but 10 times 10 is 100, and add them together, that does give you 20. This is a negative, so both of these are going to need to be negative 10s. So that's going to be x minus 10 times x minus 10. If you'd like to rewrite it this way, we can say x minus 10 squared. And there you go. Now, we have a special case. If you are familiar with the term conjugate, okay, that's used usually talking about conjugate pairs. It could be applied if you're doing imaginary numbers, okay, but it's this little format here, a plus b, a minus b. Those two guys are conjugates, which means that the middle term is going to be 0, okay? For instance, if we did x squared minus 9, okay, the two numbers that you could multiply to get 9, well, there's 1 and 9, and there's 3 and 3. Okay, since this is a negative 9 that we're multiplying, remember the choices are a positive times a negative would give you a negative, or, and it's different but the same, a negative times a positive would also give you a negative. Okay, so one of these would have to be negative, one would have to be positive. And if you look at these two right here where the numbers are the same, a 3 and a negative 3 would give us a middle term that is 0. So the answer here does become x plus 3 times x minus 3. It's called the difference of squares. say difference of squares. Okay, the same thing is going to happen here. This is a difference, which means minus. X squared is a square number, and 36 you might recognize as 6 squared. So really quick, using this property here, we can know this is going to be x plus 6 times x minus 6. Why does that work? Let's really quickly use the box method to get that going. That's going to be an x and a 6 out here, and an x and a negative 6 over here. X times x, that's your x squared. X times 6 being 6x. Negative 6 times x, that's negative 6x. And then this is negative 36. Look what's going to happen right here. Okay, that's a negative 6 and a positive 6. When you add those together, they do cancel each other out. Okay, the rest of these we can kind of just fly through. It is a difference. It's a binomial. These are both square numbers. That'll be x plus 5 times x minus 5. Here, 121, that's 11 squared. So that'll be x plus 11, x minus 11. Okay? And I think you got the idea there. So we'll just skip over these next couple and jump down here. So now, well, we've got a difference of squares right here on top. X squared minus 9. And it's already partially done for us here. That's going to be x plus 3 times x minus 3. Okay, so there we go. Factor them. Identify common factors and divide them out. X minus 3, sitting here in parentheses, is on both the top and the bottom. So we can cancel that out. That means we've got x plus 3 over 1, if you want to leave that there. Or since that 1's not really doing anything, we can just say x plus 3. Now remember, I have a whole lot of exclamation points here. You cannot cancel out an x if it has addition or subtraction next to it. If you have addition or subtraction there, the whole thing is a package deal. All right, like here we've got a 9 and a 3. Like, oh, hey, 3 goes into 9 3 times. Yeah, but we can't really do that because this is a package, x minus 3. You can't split that up at all. X squared minus 9. We can't split that up at all. It is a package deal unless we use factoring to do it. Okay. So here we go. Let's just take a look at a bunch of these here. On top, x squared minus 25. That's another difference of squares. Okay, it's a binomial. We're subtracting difference. Both of these are perfect squares, giving us x plus 5, x minus 5. And the top and the bottom both have x plus 5s. So what you're left with is just x minus 5. Alrighty. Over here, we've got two things that we can factor. We've got x squared minus 9. It's a binomial. It's a difference. And both numbers are squares. So we can say x plus 3 times x minus 3. Up top, two numbers. Multiply them to get 9. Add them together to get 6. And again, you can make your lists like I was doing above. Also here, you might want to just try the numbers that are in the other part. So maybe 3 would be a good number to use since we have a whole bunch of 3's down here. And it does turn out to work. X plus 3 times x plus 3. 3 plus 3 is 6. And 3 times 3 is 9. So again, this time, since we have the whole package to cancel, we have an x plus 3 here and an x plus 3 here. Now this one can only cancel one of these. The other one would need to have another x plus 3 on the bottom to cancel out as well. So we've got as a final answer x plus 3 over x minus 3. Okay, let's just do one more of these. Let's do this one over here, number 27. Okay, the top is x minus 7. You can't do anything with that. X is to the first power. It's just a first degree binomial or linear. Down here, though, we can factor it. You're looking for two numbers. When you multiply them, you get 49. When you multiply them, you get negative 14. In this case, it's going to be a negative 7 and another negative 7. And since there is a negative 7 up on top, we can cancel those out. I wanted to do this one because the bottom is x minus 7. That's plain to see. The thing is, there's nothing left up on top. We canceled everything that's there. You got to remember, this is multiplication and division. And the identity for that is the number 1. So just like, let's see, right here, we put it over 1 when there was something left, but it really didn't matter. Well, here, it really does matter. We have a denominator. Well, if you have a denominator, you do need to have a numerator, and in this case, it's going to be 1. So we've got 1 over x minus 7. All right, we'll skip over the rest of those. Now, certain rules in math are unavoidable. There's one for division. You can never divide by 0. In my classroom, I like to just give an example. Siri, if you've got an Apple device, does have a nice little statement in there. Hey Siri, what's 0 divided by 0? She'll give you a cute little answer. I won't play that for you right now, but on your own time, or if you want to look that up, it's kind of neat. The denominator of a fraction can never equal 0, like I just said. That means we need to find out whatever number would cause the denominator to equal 0, because that's what we can't use. Okay, so set the denominator equal to 0 and solve. Here's our denominator, x minus 3. Okay, well, here's our basic equation. X minus 3 equals 0. Add 3 to both sides, and x equals 3. Okay, now we did already simplify this one, if you remember. That was way back over here. There it is again. Okay, so we already know it's going to be x plus 3. What we need to include now, I'm going to put a comma there, is that x does not equal 3. Okay, you're not allowed to have an x that equals 3. Even though here it doesn't look like there's a problem, okay, you got to go back to the original. Okay, if it's excluded at the beginning, it's excluded for all time. Okay, guys? All right, well, let's do one of these. How about, I don't know, 40? It looks a little different than what we've already done. Up top, we have a difference of squares. X squared minus difference, 81. That's going to be x plus 9, x minus 9. Okay. Now on the bottom, we've got 27. Now, we already have 9s up top, So I'm already thinking about using the number 9, and 3 times 9 does give us 27. But how do we get 6 out of that? Well, here's the deal, guys. This is a negative 27. So like I said before, positive times negative or negative times positive, if they are different signs, then the answer is going to be negative. Okay, so one of these two guys is negative. All right, what we're trying to make is negative 6. So either 3 minus 9 is negative 6, or 9 minus 3 is negative 6. One of those is a true statement, one of those is a false statement, and it's this one here that is good. Okay, 3 minus 9. So 9 is going to be the negative one. You've got x plus 3 times x minus 9. Okay, now stop. Wait a minute. Before we finish up the problem, I want to go ahead and take a look at both pieces of the denominator. Okay, we do need to look at x plus 3 equals 0. And we need to look at x plus 9 equals 0. Okay, these two statements are set in stone. X is not going to be allowed to equal negative 3, and it's also not allowed to equal positive 9. I don't know why I wrote x plus 9 there. That is total foolishness. There we go. Sorry about that. Okay, so it's not going to equal 9 or negative 3. Now looking at what we can cancel, we can come back here. There's a minus 9 and an x minus 9 here. So the final answer is going to be numerator x plus 9, denominator x plus 3, comma, x cannot equal negative 3, as we can still see here, but it also cannot equal 9. Okay, that was an excluded value for the original, and it's also not allowed to be a part of the simplified version either. Okay, guys, that is basically it. Okay, obviously there's more examples on here if you want to try them yourself. If you're in my class, we can talk about it at 6 o'clock when we do our class conference through Schoology. But that's basically it. The next video that we do live, we're going to talk about how in this case here, for instance, there is a big difference between the negative 3 and the 9. They're both excluded values, but the negative 3 still looks like it's excluded at the very end. The 9, we just kind of had to remember that since the beginning. So that'll be our next topic, which will lead us directly into graphing rational expressions. All right, guys, I'll talk to you next time.